Example 10.9.2. Quite a short and quick example, this one. It's actually no more difficult than example 10.9.1 in the previous video. But I'm going to approach it in a slightly different way, just to set you up for the following questions, which will be more difficult. So I'm using the method of separate the variables and integrate. And the method is to separate the equation so all the y's are on one side and the x's are on the other side. Of course, it doesn't have to be x and y. In this equation, we've got v and t. In the notes, the second important point was that we can only use multiplication and or division when separating the variables. So here, just one step will get me there. Treating dv by dt like it is a fraction, multiply both sides by dt, and we have separated the variables. The first key point is met. The dv and the dt must be in the numerator, so they are not in any denominators on each side. Now we've done that, now integrate both sides of the equation. So the integral of an invisible 1 with respect to v, and on the right hand side the integral of 3t with respect to t. So the left hand side is v, the right hand side 3t squared over 2 plus a constant. There's no point putting a constant on both sides. Let me just demonstrate if we did that. So if we put constant number 1 on the left hand side and then constant number 2 on the right hand side, if I then take away c1 from both sides, then over here I've got c2 take away c1, a constant take away another constant. Well, a constant take away a constant will just be a constant. So we might as well just rename that as c. So there's no point putting constants on both sides, just one side is enough. So there we go, very short example. We've solved the equation. Solve in these differential equations means get rid of the derivative, and that's what we've done.